This is for Year 12 methods. It comes out of the Technology Refresher Masterclass question number 8, exponential models. Which base should I use and how do I get exact answers? Well, I've been given 4 pieces of information and I have decimal answers here. So I'll be thinking maybe I'll only get decimal answers. I won't get exact since what I'm entering could be rounded values. Okay, so I'll go over to mean. You want to go into statistics. And I've already entered these numbers in here. Notice that list 1 has the x values, 1, 2, 3, 4. List 2 has the y values. But it seems as if I don't have all of the answers. For example, that's 41.9904, but I've only got 41.99. If I touch on it, you'll notice that I actually have all of the values. Just because the column width wasn't wide enough, it didn't show them all, but they all do exist. Okay, so I'm going to use AB exponential first. So calculate regression, AB exponential. I could use exponential regression. I'll use AB exponential regression first. Yes, my list 1 is x and my list y is list 2 is y. Okay, and there's my answer. A equals 4 and B equals 1.8. So we've got y equals 4, 1.8 to the value to the power of x. And okay, and it draws it for me. So AB exponential uses a base, which it will then determine the base for you, and it will determine the initial value. Okay, that's good. What would happen if I chose instead exponential regression? Well, that's going to use the general form, which is AE to the BX, and it's using base E, whereas AB exponential uses base B. Okay, and oh, it didn't give me exact numbers, did it? So y equals 4e to the 0.5877867x. That's a bit of a shame. I wonder if these are the same things. So I might go OK, and I might go back into main, because in main it's exact. And if in main I had, bring up my keyboard, variables, A, math 1, E, variables, BX. So that's my general rule. And what I might do is I might go interactive, define, and I'll define it as f of x. And I know that f of 1 equals 7.2, and I know that f of 2 equals 12.96, and if I was to bring up my simultaneous equations and I put f1 equals 7.2 in the first and f2 equals 12.96 in the second, and they solve that for a comma b, I get 2 answers. Of course, a equals 4. And if I take this b answer, I bet you this b answer gives me 0.5877. XE, and turn it into decimal, 0.587786. So in actual fact, B is, if I was to use the exact notation, y equals 4e to the, what have I got? B is minus log base e of 5 plus 2 log base e of 3, which equals log base e of 9 on 5. So I've got log base e of 9 on 5 times x. That's the exact values. Okay, so what have I got here? I've got this, which I will copy and put into a new line, paste, and I'm going to go math 3 given a equals 4, given b equals this, I can go xe, and I can graph, and I can go like that. And my other rule was for bracket 1.8 bracket to the power of x, and if I take that and drag and drop, I get identically the same curve. So this answer and this answer are identically the same, except this uses base 1.8 and this uses base e, but they're identically the same